We have sent robots to Mars. We have photographed galaxies billions of light years away. But beneath our feet lies a world we barely touched. The deepest hole ever dug by humans is the Kola Super Deep borehole in Russia, reaching a depth of around 12 kilometers in 1989. Considering the Earth's diameter, this is just 0.2%, or you can say merely a scratch. So today, let's ask a question. What if we drill through the Earth? To drill this borehole, we will have to choose a stable place on the surface of Earth, which is relatively free from tectonic and seismic activities. So, for this project, we're gonna select a spot on one of the most stable regions on this planet, the Canadian Shield. It has not moved in billions of years, no volcanoes and very few earthquakes. The goal is simple in theory. Drill straight down, pass through the crust, the mantle and the core, and come out exact opposite side of the planet. The first 70 kilometers take us through the Earth's crust. Here, rock is solid and fractured, and as you go down, temperature rises fast, about 25 degrees Celsius for every kilometer. You can imagine this thing from the fact that in Kola Super Deep borehole in Russia, the temperature at the bottom was more than 180 degrees Celsius. This was the main reason for suspension of this project, as the drilling bit started melting. So instead of using any normal drilling bit, we're gonna use a large diamond reinforced drill heads with superheated fluid flowing inside to cool the system. And this drilling system will be AI controlled that can adjust itself in response to pressure and cracks. And with this, we can drill all through the crust up to 70 kilometers deep, reaching at a boundary called the moho, a transitioning phase between crust and mantle. And from here, things will get weird. The mantle makes up most of Earth's volume. It is not molten like lava. It is solid, but under extreme pressure and temperature, it acts like thick honey. At the same time, temperature climbed past 1000 degrees Celsius and the pressure would be crushing. So, we will have to develop a new kind of drill here. A kind of nozzle that will produce superheated energy in the form of plasma that vaporize stones. Behind this nozzle, there will be a hollow cylinder filled with coolant that can instantly cool down the tunnel walls. And this sudden change in temperature will convert that vaporized rocks into a glass-like ceramic, forming a protective lining. Because of less temperature inside the tunnel, this outside heat won't be able to melt this lining. You can understand this thing from the fact that we can burn a polythene filled with water. This is because the temperature difference inside and outside. Let's continue our story. The deeper we go, the rock tries to squeeze the tunnel shut. To survive this, the bore must constantly reinforce itself by maintaining a cooler temperature inside. And after 3000 kilometers, the drill reaches the edge of the core, the outer core. A vast ocean of liquid iron and nickel, hotter than the surface of sun. And the main problem here is you can't drill in liquid. So the drill becomes something else entirely. Since this is a molten metal and highly conductive, we're gonna use two huge magnets to generate our desired movement in fluid. A magneto-hydrodynamic exclusion column. Giant magnetic field push the molten metal aside, creating a temporary tunnel. For a moment, Earth's magnetic field wobbles, auroras flares across the sky, and then drill reaches the inner core. The inner core is a solid ball of iron, squeezed so hard to stay solid, despite the temperature of above 5000 degrees Celsius. Since we are already drilling above this layer, pressure will decline and it will also turn into a liquid. And there is one more thing. As we reach the center of the earth, gravity disappears and we will be in a floating position. We are going to release a small marker here made up of special material that can withstand temperature of at least 6000 degrees Celsius. This marker would be engraved with all human languages and would be suspended in the center of the earth. After doing this, the drill begins climbing upward. Now, gravity pulls in the opposite direction, and after years of work, the drill finally emerged beneath the Southern Ocean on the opposite side of Canadian Shield. The ocean gonna cools down the exit point instantly and the scars would be covered.